So, hi everyone, welcome to our presentation. My name is Tejaswan Naidu. I'm currently pursuing BTech CSC, specialized in the Artificial Intelligence and the Data Engineering in Lovely Professional University. So, today we're going to discuss about the stack, which is a data structure using linked list. So, we will explore what is stack and how they can be implemented using linked list with an example, which we use in the real life, which we can see in the real life. So, before before learning about the stacks, so what is a linked list? So let's briefly discuss about the linked list. A linked list is a data structure consists of a sequence of elements, each connected to the next by pointing at the reference of the, or we can say it's an address. So this dynamic structure allows for efficient insertion and deletion operations. So if we go for what is data structure? So data structure is further classified into two types, which is linear and the non-linear. So linked list is a linear data structure. So it's a linear data structure of elements called nodes. So basically, a node consists of the data of the element data and the address of the next following node. So about its dynamic memory, it's an advantage of the linked list, which will separate the linked list from the array. So further about this dynamic size, linked list allows the stack to grow and shrink dynamically as elements are added or removed by the system. So it's very efficient for the insertion and the deletion, as linked list provides efficient operations for adding and or removing the elements, which is crucial for the stack operations. So, so what is a stack? It's a data structure follows a principle. Basically, stack is also belongs to the linear data structures. So stacks follows LIFO principle. So what is this LIFO principle? It's last in first out principle. So it means the last element added to the stack will be the first one to be removed. So the operations, if you go for the operations in the stack, they support the push and the pop operations. So push is nothing else append or addition. So push is something which will add the data to the linked list, and the pop is the one which will delete the data which is in the top of the linked list. We can say it as a head. If we add the element or a data at the end, it will be popped in the beginning. Which, if we revise the operations push and pop, push is something which adds a new element to the top of the stack by creating a new node and updating the pointers accordingly. It says updating the next nodes accordingly. So pop is something which will remove and returns the top element from the stack by deleting the element from the stack, by deleting the first node of the linked list. As we are pushing or adding the element in the head part of the linked list, we'll also pop the head of the linked list, the element at the head. So there is also a func operation which we can observe in the stack, which is peek. So peek is something which will retrieve the top element from the stack without removing it. So the difference between the pop and the peek is peek will display or return the data in the top of the stack, but the pop will return the data as well as it will delete the data from the linked list. So what are the advantages of the linked list? So it's first of all, it's dynamic size. Linked list allows the stack to grow or shrink dynamically. And like stacks are implemented with linked list provides a versatile and efficient way to manage the data. They find application in the various fields of computer science and software engineering, including algorithm design, expression evaluation. For the example, for the expression evaluation is something we can observe in the form filling things. It's like when you need to add something, we can also find this linked list to find the corresponding bra brackets. If we take an example, consider navigation in certain app. Navigation history management, one of the basic implementation of stack. So a stack is used to keep the track of the user's navigation history within the app. Each time a user moves to a new screen or action pushed onto the stack, this allows for easy navigation back through the app by popping the screens out off the screen in the reverse order. From data management, stacks are utilized to manage the data entry forms, which we discussed earlier. As user fills out the fields or inputs, each entry is pushed on the stack, ensuring the efficient handling of user input. And So these are the basic applications of the stack, which we can observe on certain apps like Thread. So now we're gonna discuss about an example which we can see the stack using implemented by the linked list. So now we're going to discuss about an example, which is a real life example, which we are concentrated on a CRED app. So consider an app where we use a stack. So example, if you open some app, you can see some home screen, login screen, dashboard, and those things. So if you click on home screen, so you're in the present screen is home screen, and if you click on the login screen, so when you open some app, you can see the home screen. After that, if you do some task, it will go to the login screen to save the login credentials of the user. So there, after the login, you are directed to the dashboard. So you can implement stack for this process. Example, as you opened an app, so consider we are making stack using linked list. So there will be a head. So this is head. So head will be the current screen. So the screens will be the home screen, the login screen, and the dashboard screen. So the head, the present screen. So in the beginning, if you open some app, the present screen will be the home screen. So we'll just write this as home, and the next. So this will be null. So this is the present. So if you click on something, so this is home screen. So if you go further, so if you open something, like if you go into some app, you can like assume that you want to see the home screen. So after going to the home screen, you're directed to the login to save your details, to save user details, the app. So here, the head will be replaced with the login. So this will be the present screen. So here, will be the login screen. So this one will be the login screen. So here, the after the login, like the before login screen. So this is in sequence. So first, whenever you open an app, consider the create app. So here you can see. So here you can see the home screen in the first place. After home screen, you are redirected into the login screen. So this one, the head is the top of the stack, which is the current screen. So if you go further, you can be directed after the login. After you submitting your or filling the form of this login credentials, you can be redirected into some other screen. So let it be the dashboard screen. So if you are redirected into the dashboard screen, the head will be changed. The head will be changed to the dashboard. So this is D. So this is dashboard. So before dashboard, it's the login, and before login, it was the home. So this follows a sequence. You can see this. In the beginning, we started with. So in the beginning, we started with the head. So after like whenever you open an app, you can see the home. After if you want to save something, it will be redirected into the login screen. It will be redirected into the login screen. So after login screen, after you submitting all details of yourself, it will be redirected into the dashboard. So this is an sequence. So you can observe the stack. It's an application of the stack. If you want to go back, so which we can see the pop function. So here, whenever you open an app, you will start with the home page, home screen. Then it will be login screen. So here the login screen is pushed into the linked list. So here the head is the first one to be pushed. Whenever you open the app, the head will be pushed in the stack. So after opening this one, you will be directed to the login one. So login. So here the login screen is something which is appended using the push operation. So if you want to pop, so if we are at this, if we are at this phase, if you want to pop, so pop in the sense going back. If you hit back button on your mobile, on your or on your laptop, so this one will be deleted. The login screen will be deleted. So this one will be deleted. So this is the use of pop. So if you are in this phase, like you didn't went back in the before phase, and if you want to go back in this phase where you are in the dashboard screen, then this one is going to be deleted because this is the last one which is appended. This is the top of the list. So this one will be deleted. So this is the use of pop function. And if we want to learn about the peek function, so peek is something which will return the value of the top of the list, linked list. So the top of the linked list is the one which is open in the last, open in mm, the present screen. So peek will display the present screen. So this is the present screen, which is dashboard. So this one will be printed out. So we can return the value of this present screen using peek. So we're going to implement this whole function using Python, which is an application of the stack implemented by the linked list. So we're going to implement this whole function on Google Colab. So here we're gonna implement stack using linked list, which is an application of the navigation in app. So here we're gonna start with creating a class for the node. So this is a predefined function, or we can say syntax for creating a class. So we can name the class as node. So basically we'll start with the constructor and self. So self is here the current object and the data which we're gonna have in our node. So self dot data equal to data from the user, or and self dot next, which is the address of the following node. For now it will be none, as we don't know the address of the following node. So this is the class for creating a node. So the next class will be stack. Again we will, so I'm making some comments. So this is the class for creating a node, and this one is the class for the stack. Use linked list. If we go further, we will start with the constructor, or we can say as we will initialize the class with self. Here we will mention the head of the linked list. First one, we need to start with the initializing of the class tag with the self. So here we will start with the head. So head will be none because we didn't made any nodes. So initially it will be the self dot head will be then with the value of none. And if you go further, as we discussed, the first operation in the stack is a push operation. So here I named it as push. I'm defining a function which is push itself, and a d, which is an argument, or we can say it as a parameter, which is taken from the user. Uh, So this is D as a data which we want to push in the stack in the further. So here, see before pushing, like before using the push operation, here we are replacing. We need to create a new node. So new node can be created. So I'm creating a variable of which is named as new, and we will call the function, we will call the class node. So this is the method how to prepare how to create a new node. So this one will be the data um, which is given by the user. So here the new node is created. So first we need to access. First we need to know whether the stack is empty or not. If the self dot head is none, so if the self dot head is none, the stack is empty. So we can just we can just add the new node to the self dot head. So self dot head, which is none, which says it's an empty stack, will be replaced with a new node. So else, if the stack is not empty, we need to save the previous head, and the head will be overwritten by new one, and the new dot next will be the node the previous head. So we can just write the self dot head is the new one. So we can directly write so here we are saving the address of the new node with the previous head. So the previous head will be following the new node. So I can write a comment here which says push is used to add an element, use it to add an push is used to add an element to the top of the stack. And here we're creating a new node. So this is how we create a new node, as I discussed earlier. So here we are replacing the previous head with the new node, and the previous head is followed by the new node. The new node, yeah, previous head is followed by the new node, and the second operation is the pop. So in the pop one, we'll go with the present object, and yeah, the present object, and we need to check the whether the stack is empty or not. Like if the self dot head is none, so it says the stack is empty, which will leads to the stack underflow. If the stack is empty, we can't pop anything out because it's already none. The value of the stack is none, so we can't pull any, we can't pop anything. So it will leads to the stack underflow. So we will just we'll just print. We can use return, or we can just print the message out. Stack is empty. So by this we can avoid the error, which is stack underflow. And if the stack is not, if the stack is not none, then we need to replace. Then we need to replace the head. And so here we go. So not equal to self dot head. We save the head in the variable named as not, and then self dot head equal to self head dot next, or we can write it as node dot next. So node is the node dot next. So which says self dot head dot next. So it will be overwritten. The self dot head will be overwritten with the head dot next, the element which is followed by the head. It will be overwritten by the element which is followed by the head. So this is the pop function, and I can add a comment here. So what is pop? Pop is used to return new return and remove the top element of stack. So this is how we will pop the top element of the stack. And the last one is peak. We will use the current object. So if the stack is empty, which we can find out by self dot head, self dot head is none. If self dot head is none, it says the stack is empty. So we can return the message that stack is empty. If not, so if it is the stack is not empty, we can just print or return the current screen, as we are making an working application of navigation in an app. So the current screen will be the top of the head of the linked list, which we can just write self dot head dot data. So this is how we will peek. So this is a function we can add a comment here. So peek is use it to display doesn't write as return the data of the of the top element. So this is the use of stack. So we are defining a display function which will display the all elements in the stack. So display. So we want to display current object, which is the self. I will write down the comment. So displays so displays the data in the stack. So the last one at the top of the stack will be displayed in the beginning. So the code will be like so. I define a function which is display, and I'm printing the and if the stack is empty, we can't display anything. The stack is we just need to pass a message. The stack is empty. So if self dot head is none, if self dot head is none, which says the stack is empty, I will just print or return a message that says stack is empty. Else, if the stack is not empty, and we need to be careful with the indentation. If the stack is not empty, we will save the present head, the top of the stack in the variable node. So node equal to self dot head, and we will run a while loop, which will where we are accessing the element in a sequence, and we will print from the beginning. And while we are going through each element, we will print the each element's data, each node's data. So while the node dot next, which is the self head node dot next, is not empty. If it's not empty, we will print the data which is stored in the node by using node.data, and we will rewrite node with node.next, the following node. So using this line, it will keep on trying to reach the end of the linked list. So after reaching the end of the linked list where the node.next is none, so there, if the node.next is none, the last element's data won't be printed it out because it will come out of the loop. So we need to print the last element's data too. So we will print it out of the loop using node.data again. So this will print the data of the last node, which we can't print it out because it comes out of the loop. So this is how we will display the whole data which is present in the stack. So this is how it goes. And first we will create. um, so we'll go for the test cases. If you go for the test cases, first I will create a stack object, and I will call the class. So I'm creating a object named as stack. So this is how I will create an object named as stack. Then I will push using push function, which I defined here. So this is the push function. I need to provide it with an argument. So I will say in the beginning it's home screen. So I'm pushing it with home screen. So I want to just check out like whether the code is error free or not. So we can make some indentation errors. You can clear it out. Here it's connecting. You can see here. So it's connected. So everything is fine. And if you go on, so we pushed home screen. Again, the next one can be the login screen. And the third one can be the dashboard, which we also append using the push function, which we defined previously. So we appended three screens. The first one is home screen, the second one is login screen, the last one is the dashboard. So these are the three screens. So now if we pop the top screen, the current screen will be popped. So we will reach the previous from the current one. So if we want to print out the current screen, we can use peek. So peek will display the current screen. So we will just use. So we will run. So here I'm appending three. Here I'm appending the three screens: home screen, login screen, and dashboard. So you can display the whole three screens. So first we'll display object dot display function. I'm displaying. So we don't need to write anything. It will display. So so the current one, the top of the linked list is dashboard. So it is displayed in the top of the. You can see in the output, it is displayed in the top. So dashboard is the current one, so it is displayed in the top. And if you go further, the second one is the login screen, and the last one is the home screen, because the home screen is the first one which we opened, then it follows by the login and the dashboard. As it's the dashboard is in the top of the stack, it displayed in the top. So if you want to pop something, so it will be the dashboard because it's in the top of the list, top of the linked list. So I'm making the link display as comment. So I want to pop. So if I use the pop function, the top of the linked list or top of the stack will be popped out. It will be removed. So after popping out, I'm running this code and it runs successfully. And if I want to print now, I want to peek or if I want to peek, the last one is the login screen because the dashboard is popped out. As I'm using the object.pop, the last screen will be popped, dashboard will be popped, deleted. And before the dashboard, I opened the login screen. So the current screen will be the login screen. And for example, as I'm explaining it, if you open some app, you opened and you saw the home screen in the first place. After home screen, you are redirected into login screen. After login screen, after you filling the all information of yours, it will be redirected into dashboard. So you're in the dashboard. The current screen is dashboard, but you press the back button. So the dashboard, from the dashboard, you will be directed again to the previous screen as login screen. So whenever you use the pop function here, you will be deleting the top of the stack, top node or the head node of the stack. So dashboard is popped out, and you will be directed to the login screen. So here I'm making this as a comment. And if you pop again, if you pop again, even the login screen will be also deleted, and you will reach to the previous. Before the login, you open the home screen, so you will be left out with home screen. So if I also then if I peek now, I will be with the home screen because in the first pop, the dashboard will be deleted as it's the top of the stack. In the second pop, the login screen, as dashboard is deleted, the login screen comes under the top of the stack. In the second pop, the login screen will be deleted. And if we use the peek now, then we will be left out with the home screen. So the home screen will be the top of the stack. So you can see the home screen, we can see the home screen. So the current screen is the home screen as the dashboard and the login screen are deleted. So again, I'm making this is a comment, and if I perform the pop function one more time, the login screen also will also be deleted. So we will be ended with nothing. The stack will be empty. So after three pops, after using pop operation three times, the whole list will be empty as we pushed three nodes: home screen, login screen, and dashboard, and we deleted three screens. We will end up with empty stack. So now I will perform stack dot display. So as I perform stack dot display, it will display that the stack is empty because the three screens and three pops results none, and the stack is empty. And if we only use two pops, the dashboard and the home screen are deleted, and we left with home screen. And you can see the home screen is the only element in our stack. So this is how we will use the stack while you are navigating in an app, while you're navigating between the screens. So this is how you'll use. So this is one of the common example and implementation of the stack using linked list. And if we go for the overview, we created, and first of all we created a class called node to create a node. We use a constructor to save the data, and next, and here we're creating a class using linked list, which is stack, and we start with a constructor. So constructor.head is none initially. We have none, no nodes, and then there is an operation, push operation, and here new node. So here new equal to node, we're creating a new node using node, and if the self.head is none, so the head is none. It says we can just push the new element in the place of self.head. So we directly appending the new node. Else, if the head is not none, we need to replace the previous head with a new node, and we need to make the previous head following the new node. So here we are making a function, we are making a code which will. So we are saving the previous head uh, in a variable node, and the self.head, the head is overwritten by the new node, and the new node dot next, the self.head dot next will be the previous head where you can access the previous elements. So this is the pop. So if the self.head is none, the stack is empty. So we can skip the stack underflow. And we can. So if you want to write a menu-driven one, you can also write that. I want to make this docstring. So now I'm making a menu-driven program. So while true, I'm using an exception handling for this. Try. We can skip the exception handling. We can use the exception handling. So we're printing. The first one will be push operation. We can start with the create. And the second one can be the push operation. And third one is pop operation, and the fourth one is peek, push pop peek, and the fifth one can be display, and sixth one can be exit. So we can exit from the loop. So I'm asking for user input. So we are taking an integer, which can be from the range 1 to 6. So here we're taking a user input. If the user input is 1, we're creating. So first of all, we will create an object which is stack. So stack with correlation with the class stack. So I create an object called stack. So if here I created an object called stack, and as I created, I will just pass this, and elif u equal to 2. The user choose the option 2, which is push. As I created the object stack, so stack dot, we'll call the function push, and we need an input from the user. So I will write input, enter the data you want to push in the stack, and if elif else if, so elif means else if. So if he chooses the third one is pop. So stack dot will call it operation pop, and it will be performed. Elif if the user chose the fourth one, which is peak, stack dot peak, which will result the displaying of the top of the stack. If we choose the integer 5, we need to display the stack. So stack dot display, I'm calling out for the function elif if he choose 6, which says we need to end the program. So stack dot, so I can just write thanks using my code, and we can just break the while loop. So this is the menu driven program for our stack which is implemented by using linked list. So here you can see, so I'm going to run this. So here I will choose create. First I will create the stack. After that I will push. So first of all, based on our example, when we open an app, it will start with the home screen. So I will append home screen. So I started with the home screen, and I want to append one more thing. It's login screen. After opening the home screen, we can be redirected into the login screen, directed into login screen. And again, I want to append one more screen, and it's dashboard. So the current I'm in the in present I'm in the dashboard. The present screen is dashboard, as I pushed in the last. So now I want to pop. So I want to go back from the current screen. So I want to display the current screen. So I will go with the 4. So 4 is a peak. So peak will display the current screen. So the peak will display the current screen. And if you go further, we need to use the display. So stack is empty. Okay. So we need to create the object before the loop. So I'm creating the object outside the loop because the object is overwritten every time while I was running the loop. So I will restart the whole thing. So I will create, and I will append. I created the stack. So now I will push. I will append the things which I want to append. I will start with the home screen. After that, it's again I will push login screen, the second screen. So after I provide all the information of myself, I will be redirected into the dashboard. So I want to push the dashboard to. So after dashboard, I'm currently in the dashboard. So just want to know where I am. So you can see this. The current screen is dashboard. And after this, I want to go back from the current screen. So I use a pop function. So here I just went from, I just went back from the current screen. So the current screen will be the login screen. So you can see here, the current screen is login screen. If we go back again, or we can just see what are the screens we just passed through. So the login screen is the current screen, and before the login screen, we passed through the home screen. So you can see this. And if we want to go back, so we're currently in the login screen. We're currently in the login screen. If you want to go back using this back option, we can pop. So we used the operation pop. So here we went back from the current screen to the previous screen. So current screen is the login screen. So we use the pop. So we can use the peek operation. So the current screen is home screen. If we want to display the all the screens which we have passed through or which are behind the home screen are none, because the home screen is the first one which we went through. So if you want to pop the home screen, and if you want to peek the stack, it will show the stack is empty. Like stack is empty. If you want to display, we can display stack is empty. So if you want to display something, like there is nothing, it leads to the stack flow. So I just written the message a stack is empty. So that's all. We went through the all test cases, and we also discussed we just will exit from the menu driven program. So I exited from the menu driven program. So here we went to the normal test cases, and we also prepared a menu driven program. You can see here. So these are the functions. We discussed about the push operational function. We discussed about the pop operation. We discussed about the peek operation, and we also discussed about the display operation. So these are the operations which we can observe in the stack implemented by the linked list. So this is the code for the stack which can be implemented by the linked list. We can also implement the stack using linked list. So that's all. Thank you.